Okay, so you all are here, obviously. Most of the class isn't here. If any of your group members are worried that they weren't able to make it, don't worry. I'll record this and post it on YouTube or something after this. Okay, I'm just going to share my whole screen. Okay, can you all see like a PDF that's up right now on the screen? Anybody let me know? Can you see a PDF? Okay, cool, thanks. Okay, so this is the second lab report, but the first one that you do in your groups. And because it's the first one, and you probably don't have a great idea of what, a good one should look like, if you go under the lab materials folder on the course website, there's a file there called example lab report 2. I think the one I posted is a um, Word document actually, but this one that I'm showing you here is a PDF. That is just a report that I made as like an example of what I think like a 10 out of 10 report for Lab 2 should look like. So don't copy this and turn it back into me in the TAs to grade. That would not result in a good outcome. But it's to give you an example of what the report should look like or what the pieces there should be. The best way to go about this is just read the lab handbook real carefully under report 2 or under lab exercise 2, and it walks you through pretty point by point on like what exactly should be in each section of the report. And so that's the best way to make sure that you're including everything that needs to be there. This is the first group lab report in an intro level class, so we're not expecting you to show like mastery here. Like for example, part of the report here is you have to write a hypothesis, which says what you expect the results to be and why you expect that. Your hypothesis may not be great, but you'll get all of the points or most of the points for a hypothesis if you just simply categorically include one. If you don't include a hypothesis, then you'll get dinged for that. But if you include one, and as long as it's not completely absurd, you'll probably get full credit for that. So make sure you read the lab handbook real carefully and make sure that whatever you submit includes all of the specific things that it's asking you for there. Make sure on the front of your lab report, like your cover page should look something like this. Give it like a title and make it clear that it's Lab 2 for this class and the names of all your group members and your section, your TA. And then make sure you include this contributor table down here. This is what I use as kind of like a reality check at the end of this semester. Part of your grade in the lab part of the class is you do a peer evaluation of your group members. And this is to kind of protect you from anybody saying that something happened that didn't happen. Like, for example, if you get dinged at the end of the year because one of your group members says, oh, they didn't help much, they didn't help with any of the data collections, then I'll go back and look at these and I'll say, well, you said they helped with 3 out of the 5 data collections. That's not too bad. That's pretty good for a long semester. So make sure you indicate on here who exactly was responsible for what or who contributed to what. And then we'll have like a thing to check on there at the end of the semester if there's any conflicts with the peer evaluations, which usually there's not. Usually everybody works pretty well together, but sometimes situations like that come up. Okay, this first group lab report is a little bit different from the other ones. In most of the remaining lab exercises, you'll be doing exercises in the lab and you'll collect some data. But then the TAs will shortly after you do that will send you the data to work with. Like they'll send you electronic files with the data in it. This first one that you do in groups for lab 2 is not like that. You collected your own data. So everybody should write a report for the data that you collected in your group. And so if you're comparing like, results to like another group, you might have different looking data and maybe even different results in terms of like the rank ordering of things and the exact numbers, of course. So don't worry too much about that. Everybody walks and runs a little different, and you may have different looking results than other groups, and that's okay. That's expected in this. But there's no particular file you'll be sent that has the data in it. You should in each group already have your own data, and then we need to work with that data. So I recommend pulling up just a blank spreadsheet like this. So hopefully you can all see my Microsoft Excel spreadsheet here. And let me make that a little bit bigger. Let's go 125. Okay. So in this lab exercise, we did, I think, 6 different conditions. You did a normal walking speed, and then you did speed a little bit slower than normal, speed a little bit faster than normal, a very slow walking speed, a very fast walking speed, and then a self-selected running speed. Okay. So we have six different conditions. That's the first thing I'm going to write down here. So condition. And then under each one of those conditions, you did five trials of that condition. So five repetitions, for example, of the participant for your group walking at their normal speed, for example. Okay, so we had a condition, and then under that condition, we had a number of trials. Okay. So this is how I would structure it. We did a normal walk, and we did that five times. So I'll copy paste that five times. And then we did five trials in there. Okay. Then I also did what I'll call the slow walk. And we did that three, four, five times. And then I'll copy paste that. We did a fast walk. One, two, three, four, five. Whoops. Four, five. And I did that five times. We did a really slow walk, or I'll call that slowest walk. One, two, three, four, five. We did a fastest walk. One, two, three, four, five. And we did a run. One, two, three, four, five. Okay. So 30 trials total, five in each of these six conditions. Normal walk, slow walk, fast walk, slowest walk, fastest walk, run. In each one of those conditions, for each one of those trials, you should have a distance that you covered. You should have a time in seconds that it took you to cover that distance. And you should have a count of steps that it took you to cover that distance. The distance might vary a little bit. Sometimes the TAs have you set it up a little bit different depending on where you did it. Some of them did it in the lab. I saw a few groups doing it outside. But you should have a measured distance that you covered here with each trial in each of these conditions. Normally it's something like 15 to 20 meters. Just to make the math easy here, I'm going to assume it was 20 meters, but yours might be slightly different depending on what exactly you did and what you measured. That'll be the same for all these. So I'm just going to fill that in for all 30 of my trials here. And then you should, for each trial of each condition, have a measurement of the time that it took you to cover that distance. Okay. So to cover 20 meters when I'm walking at my normal speed, I'm just going to make some numbers up here. That might have took me 16.1 seconds, and then maybe 16.8 seconds, and maybe 15.5, maybe 16.2, and maybe 16.7. Okay. And then you should also have a count there of how many steps it took to complete that bout of walking there at that particular speed, and for each of these trials. So maybe the first time was something like 30 steps, and 29, 28, and then 30 again, and then 28. Okay. And then maybe for the slow speed, that'll take me a little longer. So maybe that took 20 seconds, and 21.5, 20.9, 2, 6. And then maybe that took me 33 steps, 34, 33, 34, 35. Again, I'm just making up numbers here, but you'll have actual measurements that you hopefully took in the lab last week that you'll populate each of these trials for each of these conditions with. Okay. I'm going to stop there just for the sake of time, but for yours, you'll fill in all of these here. So I filled in numbers there for the distance for all of them, the time for the normal walk trials, the time for the slow walk trials, and then the steps for the normal walk trials and the steps for the slow walk trials. But you'll hopefully have values there for all these other four conditions too. Okay, so that's it for data entry. Does anybody have any questions there? Anything I did there? Pretty straightforward. Just set it up with all your trials and conditions and then punch in all the numbers that you measured there. But any questions before I move on? Okay. So from those measurements, then you'll do some calculations. Okay. This is kind of the central data collection thing in biomechanics. Often the data that we directly measure is not what we want to know to make conclusions on. So I have distance, time, and steps, but that's not all that informative about biomechanics. I have to take those data and do some math and physics and physiology operations on them and turn them into biomechanical data that are more interesting. So the first more interesting thing you want to calculate is speed, and that'll be in meters per second. And you'll calculate this for each one of your trials. So each of these 5 trials in each of these 6 conditions. And speed is just simply equal to the distance that you covered in that trial divided by the time that it took you to cover it. Okay. For walking, a slow walking speed would be like somewhere from 0.5 to 1 meters per second. A very fast walking speed would be like 2 meters per second or faster. And like the fastest speed that anybody like runs at for any appreciable distance is, maybe 10 meters per second for like a world-class sprinter. So just to give you kind of a bounds on what numbers you should be expecting here if you're doing this right. You should be getting walking speeds of like 1, maybe 2 meters per second, and a running speed of, depending on how fast you chose to run, to maybe 3 meters per second, just to have kind of a check there. Okay. So that calculation is the same for all trials of all conditions. Speed varies, but it's always calculated as the distance divided by the time. So we can just fill that in there. Then speed, remember, it's the product of two temporal stride parameters, the stride frequency or stride rate, how quickly you take strides, and the step length, how long you cover in each one of those steps. So my step rate, that is units of hertz or steps per second, there I take my steps and I divide by my seconds, and that gives me my step rate, and then fill that all the way down. And then lastly, I get my step length. And you can get that a couple ways. You can either take your speed and divide it by your step rate, and that'll give you a step length. Or you can take your distance and divide it by your number of steps that it took you to cover that distance, and that'll give you a step length. And notice in both of those examples, so notice here 0.6666, blah, blah. If I do it the other way, speed divided by step rate, I get the exact same number, right? So a couple different ways you could do this calculation, but because these variables are all connected and related to each other biomechanically and through the physics involved, it doesn't matter which way you calculate it, do it either way and you get the same result. So you can think of step length as well, take the speed and divide by the step rate and it backs out from that. Or you can just directly calculate step length as how far did I go total and how many steps did I take to cover that. Okay. Okay, those are your 3 outcome variables that you want to calculate in each trial of each condition. Um, After that, the reason we take multiple trials for stuff like this, like why did we do the normal walk 5 times instead of just 1 time? Humans are variable. When we're given a task of walking at our normal speed, we don't always walk at the same speed. We don't always take the same amount of time or the same number of steps. So typically in science, we'll have somebody repeat the task several times, and then we'll average over those different trials or over those different attempts to get kind of a representative value that represents, typically or on average, what does this person do? Okay. So after you finish populating your sheet here with individual values for speed, step rate, and step length for each trial, then you want to, within each of these 6 conditions, average those variables over those trials to get within each condition an average value for that speed and for that step rate and that step length. Okay. So I would do that just somewhere over here off to the side. I'll make like a new section here called averages. And I'll say for my condition, got my normal walk. There's something in the chat here. 1 second. Function for step rate and step length again. Yeah. So let's just start from scratch. Speed is equal to distance divided by time, right? How far did it go and how long did it take me to cover it? And I'll copy that down for everything. Step rate is how quickly am I completing steps, right? So you can get that from how many steps did you take and how long did it take you to do them. And that gets you your step rate or steps per second, which becomes cycles per second or hertz. And then step length, there's two ways you can do that, but regardless of how you do it, you'll arrive at the exact same numerical value for step length for all these trials because they're the step length and the step rate and the speed and all these variables are all connected to each other by physics and by the mechanics involved. So because speed equals step rate times step length, if you know speed and you know step rate, you can just do speed divided by step rate, and then your step length falls out of that. Or you can do step length as how far did I go, divided by how many steps did I take to go that far. And notice no matter which way I did that, I got the exact same step length both times because these variables are all physically connected to each other. So it doesn't matter how I calculate it, they're both correct and they both arrive at the same value there for all those step lengths. Okay. Um, Normal walk, slow walk. And again, when you actually do this for your reports, you'll have these other conditions here. So you'll have a fast walk, and you'll have a slowest walk, and a fastest walk, and a run. I'm not going to do all that here today, but just showing you some examples of what this will look like. And then for each of these variables, let's say speed in meters per second, you'll have a mean and a standard deviation, or SD. Okay? Some of you have probably taken statistics classes, some of you probably haven't. Mean is just the average value of these five values. Standard deviation is like the variability in that value around that mean. So let's, for example, here for normal walk, do the mean. I just say average, and then I select in parentheses those five trials for normal walk, and then close that, and it gives me that average value there. Um, Standard deviation, you do STDEV, and then highlight those same five trials, and then close that out. Okay. So mean here, that kind of makes intuitive sense. Like that's just the average speed, right? One time it was 1.24, then 1.19, then 1.29, yada yada. Average all those together, and it's on average in the normal walk, you walked at that speed. Standard deviation is kind of the variation around that mean. So the bigger that standard deviation is, the more variable your walking speed was from trial to trial here within that normal condition. Strictly speaking, these are like if it's one standard deviation, that means like roughly 2/3 of my trials were all like this close to the mean. And then if you double that, it says like nearly all of the trials were within two standard deviations of that mean. So the bigger it is, the more variable your performance was within that particular condition. So we'll do that for speed. We will also do it for step rate. Have a mean and a standard deviation for that. So I'll do the average of my 5-step rates for that condition. And then STDEV, standard deviation of those 5-step rates. And then lastly here for my step length, where again, I'll have a mean, the average of my 5-step lengths, and then standard deviation, STDEV, of those 5 repetitions. Okay. Now we had one more variable that we measured, that RPE, at the end of each set of 5 trials of that walking speed or that run. You recorded the rating of perceived exertion, RPE, for that participant performing that one. And that one, I believe the instructions were you just do that one time. So you won't have a value of that for each trial, but you'll just have one value for how hard they felt normal walking was in general. Or and same thing for slow walk. There won't be 5 different values. You'll just have one value for the RPE for slow walk. So for that one, you won't have a mean and standard deviation because there's just one number for it. So maybe this one was a 3 and maybe this one was a 2, for example. And we only submit one Excel per group. The Excel sheet doesn't actually get submitted. You can submit it if you want, but you'd have to like convert it to a PDF and like stitch it onto the end of your report, which you can do if you want. The Excel sheet here is to help you make the graphs in the results. So if you scroll through the report here, you'll see under results, there's some charts there that are plotting like the mean and standard deviation at these different speeds for step length and step rate, for example. So that's what the Excel sheet is for. It's helping you make these plots that you would then put into your report, but you don't have to actually submit the Excel spreadsheet as part of the report. You can if you want, but it's not something that's required to be submitted. One lab report per group. Yes, each your group submits one report. You all need to each submit one report. Okay, so that's where you'll get your data from. So for example, let's just do slow walk here. So I will do average of my 5 slow walk speeds and then a standard deviation of my 5 slow walk speeds and then an average of my 5 slow walk step rates, standard deviation of my 5 slow walk step rates, average of my 5 slow walk step lengths, and then standard deviation of my 5 slow walk step lengths. Okay. So again, when you actually do this for your actual reports, you'll have values here for these other 4 conditions here. I'm leaving those blank for now, but it should generally resemble this process. And you don't have to, like, strictly speaking, copy my format here. Remember, you don't actually turn this sheet in. This is just to help you make the graphs in the report. But something conceptually similar to this is probably what you should be doing. Okay, so suppose you have things here, and I'm just going to make up numbers here. Let's suppose that the fast walk was an average speed of 1.45, a standard deviation of zero point 0.05, and maybe the step rate was 0.9, 0.07, and maybe the step length was 0.75, 0.03, and maybe RP was 4. And then slow walk, maybe that was 0.7, 0.04, and maybe this ends up being 1.2, 1.05, and that should be pretty short, so maybe 0.49, 0.04, and maybe 1. And then fastest walk, maybe I could get up to 2.1, 0.07. This might be 2.2, 0.06. And this might be pretty long. This might be 0.8 or maybe 5. And then maybe run. Maybe I ran at 2.5. Okay. Again, I'm just making up numbers there just to populate the chart here, but you'll actually calculate those from your values over here that you measured in the experiment. Okay, when you get all of your means and standard deviations for all the conditions for speed, step rate, and step length, that's then when you will make the graphs from these data that you then put in your report. Okay? The graphs that it has here, that it asks you to make, there's 3 of them. All 3 of them are plotting speed on the x-axis. Okay, so that's this variable here, the average speed. But then on the y-axis, they're plotting different variables in each of these plots. Okay, the first one is speed on the x-axis, and then step length on the y-axis. Second one is speed on the x-axis and step rate on the y-axis. And the third one is speed on the x-axis and RPE on the y-axis. So let's see how we might make one of these. Let's suppose I wanted to make a graph of speed on the x-axis and step length on the y-axis. Again, there's lots of different ways you can do that, but the way that I recommend doing it is you highlight your speed, And then y'all can't see my keyboard here, and I'm on a Macintosh. This might be slightly different if you're doing it on Windows, but I'm going to hold down the Command key on my keyboard, and then I'm going to highlight the data that I want to put on the y-axis. Okay? And that's going to be I want to do step length. Sorry. So let's highlight speed. I want that on the x-axis. And then on the y-axis for this plot, I want step length. Okay? So to get the speed, I just used my trackpad here and selected those 6 cells. To also grab the step length, if I don't hold down the Command key and I click on this, then it got off my speed. Okay? So if I highlight my speed, then hold the Command key, and then highlight the mean step length, then it's grabbed both of them there. Okay? Now, if I go then to Insert and go over to my charts here and make a scatter plot, okay, then I get a chart there, an ugly chart, but a chart nonetheless, that's got speed on the x-axis, that first variable I grabbed there that it's got highlighted in purple now, and step length on the y-axis. Okay. Now, Excel makes ugly charts when you just kind of auto-generate a chart here. So let's pretty this up a little bit. Delete the title. You don't need a title. You'll have a caption in your report here, like figure 1, that tells me, what's in this chart or what's in this set of charts. So get rid of that title. Then we want to put on the x-axis a label for that axis, a title for that axis, and on the y-axis, a label for that axis. Again, this might be slightly different on Windows Excel if you're doing that, or if you're doing this in Google Sheets, it might be slightly different, but this is how you do it on Excel and a Macintosh at least. Go to Chart Design, and then under Add Chart Element, it'll let you add a bunch of features there to your chart. And if I go down to Axis Titles, I can say add a primary horizontal title, and you'll see an axis title pop up there. And then I can go back and I can say add a primary vertical title. Okay. And then if I click on my horizontal title, I can go in there and name it. So I'll say this is speed in units meters per second. And I like to make it bold, so it's a little offset there. And then here on the y-axis, that was step length in units of meters. And I again like to make that bold. Okay. So now you can look at that and you can go back to my example here and you can say, okay, it's starting to resemble that plot that we had there in the example. These are what I think in the example of nice looking plots. You don't have to make it look like that, strictly speaking, but try to make something that kind of roughly resembles that. Don't just use the default like Excel plot there. It's often not clear like what is actually shown. So at a minimum on every plot that you ever make, it should always say on the title what is on the x-axis and what are its units, and what are on the y-axis and what are its units. Okay, so I'll always at a minimum include that information. Beyond that, you can get into how many significant figures and what colors you make and all. That's all just kind of window dressing. But always tell the reader what data are shown here, like what are the names of these variables and what are the units of those variables. Okay. One thing you'll notice on the chart is it's got these error bars around it. Those are those standard deviations. So this value here, let's go to the one in the middle. That's since it's the third slowest speed, that's probably my normal walking speed. And so the value of the blue circle there, that's my mean step length for that condition. And then this error bar here is 1 standard deviation above that mean. And this other one down here is 1 standard deviation below that mean. Seems like it'd be a simple thing to add those error bars there. Like if I click on my data here, usually it highlights all of them. See, it's got each one of those points highlighted. And then if I go back to my chart design and go to add chart element and go to error bars, oh, okay, error bars. But then it's got all this stuff here. And if you go to standard deviation, remember I said, okay, here's standard deviation. So let's stick those as my error bars. If you click that, it sticks something on there that doesn't look anything like what I have in my example there. So I don't know what that kind of default standard deviation option is doing in Excel, but it's not doing what I want it to do in this class. So let's see how we actually get these standard deviations that we calculated to be those plus or minus error bars. So I'm going to go in there and delete those because that's not what I want. Then I'm going to highlight my data again. And I'm going to go to add chart element, and I'm going to go to error bars, but I'm just going to go down here to the bottom where it says more error bar options. And that pops up this format error bars set of options over here on the right. And there I'm going to go to my direction. I want this to be plus and minus. That's fine. And under my error amount, I want that to be a custom amount. And then next to my custom amount, I'm going to specify that value. Okay, so I click on specify value. Then that pops up this little window here where it says positive error value and negative error value. And what that's asking for is that's Excel wanting you to tell it where on this chart is the set of values that you want to have error bars going above these data points. That's this positive error value. And then likewise, where in the data on this chart are the values that you want it to go below those 6 data points. Okay. So for my positive one, I'm going to click on my, select stuff on the chart here button. And I'm going to pick those 6 standard deviation. Oh, sorry, that's for speed. That's the wrong one. I want it for step length, these ones here. So that's saying take those 6 standard deviations and make them the positive error bars on these 6 mean data points there. Okay. Then likewise for my negative error bar, I click that. And I'm going to go select those same 6 standard deviations and push return. And then if I click OK, then that should populate my chart here with those vertical error bars that are actually the values of those standard deviations that I calculated. Sometimes it's got these sideways ones here. I don't know why it sometimes puts that on and sometimes doesn't, but we don't need those. We just want the vertical error bars. So you can just click on those sideways ones if they show up and push delete on your keyboard and that'll get rid of them. Okay. So that is how you make that speed versus step length chart that is starting to resemble this one I have here. You'll do a similar thing to make a speed versus step rate chart, and then a similar thing to make the RPE chart. Now remember for RPE, for that one, we don't have any standard deviations. We just have that one value that was reported for the condition. So for RPE, you won't have the error bars. It'll just be the single value of the RPE for that particular condition. But for the step length and for the step rate, you should have the mean plotted versus speed for each of them, and then the error bars around that mean for each of them. Okay. That's about it for data processing. Again, make sure you take a look at the lab handbook that will show you all the specific things that it wants you to write about in the lab report. And if there's anything that you are unclear on how exactly to do this or what exactly should go into the report, you can check with your TA and they will be happy to help you. Okay, that was all I was going to cover here, and I'm happy to stay on and answer any questions if anyone has them. And I will post this up and get a link out to have this for everybody to view after I get off the Zoom here. Somebody asked where can I find the recording. I'll post a link to it on the announcements on the course website once we get off here. It'll be a little bit. It might be later tonight.